French, German, and Spanish. I will start my talk with a motivation. Then I will present our human AI-generated text corpus, which we collected to train and test our classifiers. Then I will demonstrate the features we analyzed for the classification of human and AI-generated text. After that, I will walk you through our experiments and results. And finally, I will summarize my talk and indicate possible future steps. Let me motivate the topic. Generative AIs and chatbots like ChatGPT have become available to the wide public. And for example, as you can see here, children are seeking help with their homework, students as well. Some people are using it as a daily source of companionship. Individuals are looking for medical advice. Furthermore, it is used for customer support. But as AI algorithms improve, detecting AI-generated content accurately becomes increasingly challenging, posing issues such as fake news generation, spamming, and plagiarism, and so on. Therefore, tools that can differentiate between human and AI-generated content are really crucial nowadays. Here is an overview of the research questions we are working on. The first question is, how effective are different features in distinguishing between human and AI-generated text from the educational domain? The second research question was, what impact do we have if we specifically tell the AI to generate text as a human would do it? The third question was, how do the classification results vary across different languages? And the last question was, do the features perform comparably well in the news domain? That's another domain now. Let me now say a few words about our human AI-generated text corpus, which we collected to train and test our classifiers. And if you want, you can freely access our corpus on the GitHub URL here. Since there was no corpus of human and AI-generated text covering different languages and domains in a comparable way, our goal was to create a new corpus and share it with the research community. For that, we took text from English, French, German, and Spanish Wikipedia. Additionally, we enriched the corpus with news articles from well-known newspapers covering areas like crime, entertainment, politics, science, and sports. The corresponding AI-generated texts were produced in 4 ways: basic generated, advanced generated, but also basic rephrased and advanced rephrased, because you can use AI to rephrase text as well. Here's an example of how we created the AI-generated counterparts of the human-generated text. So for example, our basic prompt to generate a text about Australia from scratch was generate a text on the following topic, Australia. Our more sophisticated advanced prompt to generate a text about Australia from scratch was generate a text on the following topic in a way a human would do it, Australia. Our basic prompt to rephrase the Wikipedia text about Australia was rephrase the following text and then Wikipedia text, Australia officially, the Commonwealth of Australia, etc. And finally, our more sophisticated advanced prompt to rephrase the Wikipedia text about Australia was rephrase the following text in a way a human would do it, and then Wikipedia's text about Australia. Let me now demonstrate the features we analyzed for the classification of human and AI-generated texts. For the classification of AI and human-generated text, we investigated features from, in total, 8 feature categories. We investigated, for example, the perplexity features, which are quite frequently used for the detection of AI-generated text. Here we computed the mean and max perplexity. We also investigated semantic features, where we, for example, computed a polarity score and measured the objectivity and the subjectivity of the texts. Furthermore, we used traditional list lookup features like stop words, personal pronouns, but also discourse markers, which help improve the flow of text. We used document features. For example, we computed the mean and standard deviation of words per sentence and the unique words per paragraph. We also used error-based features. For example, we applied grammar checkers and regular expressions in order to find multiple blends, for example, multiple characters. We furthermore investigated a so-called readability feature. So we computed the so-called flash reading ease and the flash Kincaid grade level, which are metrics used in American high schools to assess the reading level. One feature which hasn't been tried before from the research community was to simply ask ChatGPT, was this text generated by you? And finally, we used text vector features. In related work, TF-IDF vectors are usually used on word level, but we also tried on sentence level sentence vectors with the help of SentenceBird. And so in total, we came up with 37 features in our 8 feature categories. And as you can see in the table, 10 features were even completely new, never investigated by related work. Now I will walk you through our experiments and results. First, an overview of our experimental setup. We took 80% of our text corpus to train systems, which contain combinations of traditional and new features combined in different classifiers. With the remaining 20%, we fine-tuned and evaluated the systems. And then we compared our results with the results which can be achieved using the famous tools for identification of AI-generated text, ZeroGPT and GPT-0. Let's now look at the results concerning our first research question. How effective are different features in distinguishing between human and AI-generated text from the educational domain? When we take the English part of our corpus, we see that text vector features and document features perform best. The perplexity feature, which is, for example, used in ZeroGPT and GPT-0, also performs quite well. Worst performances were given by the readability feature and the error-based feature, but also by the AI feedback feature. It's interesting that ChatGPT doesn't seem to know if it has created a text. Let's now look at the results of the rephrasing. So here, the document features and the text vector features performed best as well, but the list lookup feature also was quite good. The worst performances were again by the AI feedback feature and the readability feature, but also now by the semantic feature. Let's now look at the results concerning our second research question. What impact do we have if we specifically tell the AI to generate text as a human would do it? And our hypothesis here was that prompts with a request to generate text in a human-like way make the decision of the AI-generated text more difficult. So, but what do we see here? The detection of advanced generated text is only slightly worse. For rephrased text, it is even the opposite. That means the detection is not really more complicated using the advanced prompting. And that is also supported by our baselines, GPT-0 and ZeroGPT. Let's now look at the results concerning our third research question. how do the classification results vary across different languages? And here our hypothesis was that the investigated features deliver comparable results for the detection of AI-generated text across languages. So what do we see? For the generation, the F-scores for French are very similar to English, but for the detection of French rephrased text, French is better. Let's look at German. The detection of rephrased text is slightly worse, especially in the detection of basic AI rephrased text. And Spanish is comparable to French in the detection of AI-generated text, but better in the detection of AI-rephrased text. To summarize, we see similar patterns for basic and advanced AI-generated prompts over languages, but there are more differences for rephrased text. For example, if we look at German basic rephrased, which gives an F-score of 72%, while for French, the advanced rephrasing has an F-score of 90%. Let's now look at the results concerning our fourth and last research question. Do the features perform comparably well in the news domain? And here our hypothesis was that the classification performs better for text from the news domain than from the educational domain, because we thought that there is a more subjective way of writing and different styles of writing news articles. But what do we see here? A slightly worse detection of AI-generated text for news. That's here. And if we look at the rephrasing, we see a much better detection of AI-rephrased text here. For example, 98% versus 82%. Here you see the comparison of the F-scores achieved by our best systems compared to GPT-0 and Zero-GPT, while GPT-0 was only available for English. We used Zero-GPT for the other languages. And we see that we can significantly outperform these tools with our features. So partly more than 100% relative. Let me now come to the conclusion. Text which is AI generated from scratch is better recognized than text which is rephrased. And the prompting had minor impact on the performance of the systems. We obtained comparable performances across our 4 tested languages. Our systems provide comparable performances from the education domain and the AI-generated text from the news domain. News domain was a little bit harder. We significantly outperform those tools which are very famous for the detection of AI-generated text, Zero-GPT and GPT-0. Let's now look at future work. We think future work may contain a change of perspective. That means using the lessons learned from the features to improve AI text generation. And on the other hand, investigating other prompts and text domains may be part of future work. Furthermore, we could analyze other classifiers such as transformer-based models, which we haven't tried here in this work. Thank you very much.